It was the most advanced fighter plane ever built, a marvel of aerodynamic perfection, but it carried a deadly flaw that was killing its pilots and losing the war. The year is 1942. The Royal Air Force has a new American fighter, the P-51 Mustang, and they have a love-hate relationship with it. Down low, near the ground, it's a champion. It can outfly and outrun nearly anything. But where the war was being decided, in the freezing, thin air above 15,000 feet, the plane became a liability. This was where German fighters reigned supreme. The Mustang's powerful Allison 1710 engine was starving for air. Its supercharger just couldn't keep up, and as a result, every mission to escort bombers toward Germany felt like a death sentence. The pilots knew they were flying a thoroughbred with a crippled heart. But miles away, at a Rolls-Royce facility, a test pilot named Ronnie Harker was about to propose something that sounded like mechanical heresy. His engineers thought he was mad. He wanted to perform radical surgery, tear out the Mustang's American-made engine, and force-fit a monstrous British Spitfire engine into its nose. This new engine was hundreds of pounds heavier. It demanded a completely different cooling system. On paper, it was a recipe for disaster that should have made the aircraft dangerously unbalanced and impossible to fly. His colleagues called it a grotesque experiment, an unholy union of parts. But when this hybrid beast finally roared and tore through the atmosphere, it became a hunter, and it would go on to change the course of the entire war. To truly grasp why the P-51 was simultaneously a masterpiece and a failure, we have to travel back to April of 1940. A delegation from the British Purchasing Commission arrived at the headquarters of North American Aviation in California. Their request was urgent. They needed fighter aircraft, and they needed them by the thousands. The Battle of Britain loomed on the horizon, and the RAF was losing planes faster than its factories could replace them. The British initially asked North American to produce the Curtiss P-40 Warhawk under license. It was an established, dependable aircraft, a safe bet. But James Dutch Kindleberger, the visionary president of North American Aviation, had a more audacious plan, or perhaps a more reckless one. He approached his lead engineer, Edgar Schmued, a self-educated German immigrant who arrived in America with a mind full of radical designs and a burning desire to innovate. Kindleberger posed a defining question: should we build someone else's outdated plane, or should we create something entirely new? Schmued's response would echo through aviation for decades. He said they could design and build a superior fighter from scratch in just 120 days. 4 months. A typical fighter program took years to develop. But Schmued was not a man who cared for bureaucratic delays or conservative design choices. He was obsessed with a single principle: absolute efficiency. He began his work with the wing. Schmued was an avid reader of cutting-edge research from the National Advisory Committee for Aeronautics, NACA. They had pioneered a new type of wing known as a laminar flow airfoil. The concept was brilliantly simple. Instead of allowing air to flow turbulently over the wing's surface, which creates immense drag, the laminar flow design kept the air moving in smooth, parallel sheets, like water gliding over polished glass. The outcome was a wing that produced incredible lift with minimal resistance. It was aerodynamically slick, almost like a ghost cutting through the wind. Schmued paired this revolutionary wing with a fuselage that was a study in mathematical precision. He used conic sections to sculpt the body's plane, ensuring every single curve was calculated to reduce drag. There were no protrusions, no uneven surfaces. The Mustang's aluminum skin was finished to be as smooth as a river stone. Then came the cooling system, and here Schmued attempted something that no one had done before. Rather than placing the radiator in the nose or under the wings as was conventional, he tucked it deep inside the fuselage of the aircraft. He designed a scoop that funneled air through the radiator and vented it out the rear. To an untrained eye, it looked like a design oversight, as if someone forgot to properly seal the aircraft's underside. But Schmued was aware of the work of a British scientist named Frederick Meredith. Meredith had made an astounding discovery. If a cooling duct was engineered with perfect geometry, the hot air exiting the radiator would not just dissipate, it would accelerate and expand. And if the exit vent was shaped correctly, this expanding air would generate forward thrust. It was essentially jet propulsion from a piston engine plane. This phenomenon became known as the Meredith Effect.
In theory, it could completely cancel out the radiator's drag, perhaps even transforming the cooling system into a rudimentary ramjet. Schmued wasn't sure it would work in practice, but he was willing to take the risk. On October 26, 1940, the prototype, designated the NA-73X, rolled onto the tarmac and lifted into the sky. It had been precisely 102 days since the first drawing was made. The test pilots were in disbelief. The aircraft was incredibly fast, agile, and responsive. At low altitudes, it could exceed 490 miles per hour. It could turn inside a Messerschmitt Bf 109. It could leave a Focke-Wulf 190 in its dust on the deck. The British Purchasing Commission was ecstatic. They immediately placed an order for 300 aircraft. The Mustang was poised to be the savior of the RAF. And then a pilot attempted to fly it higher than 15,000 feet. The engine choked. Not completely, but it was just as bad. The Allison V1070 engine that powered the early Mustangs was a superb piece of engineering at sea level, producing over 1,000 horsepower. It was reliable, smooth, and robust, but it had a critical weakness: a single-stage supercharger. What exactly does that mean for a fighter? A supercharger is a compressor that crams more air into the engine's cylinders. At high altitude, where the atmosphere is thin, a supercharger is essential to maintain power. More air means more powerful combustion, which means more horsepower. But the Allison supercharger was a simple one-speed design. By 20,000 feet, it was already struggling to compress the thin air. At 20,000 feet, it was practically useless. The engine's output plummeted to maybe 800 horsepower. Against German fighters specifically designed for high-altitude combat, flying a Mustang was a death wish. The RAF did their best to make it useful. They assigned the Mustang to low-level reconnaissance and ground strafing missions, any role that kept it safely below 10,000 feet. In these roles, it performed beautifully. The pilots adored the airframe, but they all understood the grim reality. The Mustang would never escort bombers all the way to Berlin. It could never win a dogfight at 30,000 feet. It was a race car stuck in first gear. By early 1942, the Mustang was widely regarded as a disappointment. The United States Army Air Forces had no interest in it, having already rejected the design in favor of the P-38 Lightning and P-47 Thunderbolt. The Mustang was seen as a failed British side project, but Ronnie Harker saw potential where others saw failure. In April 1942, Ronnie Harker was working as a chief test pilot for Rolls-Royce at the Air Fighting Development Unit in Duxford, England. His job was to assess every Allied fighter, and when he was given the keys to the Mustang, he expected very little. He climbed in, fired up the Allison engine, and took off. For the first 20 minutes, he was having an absolute blast. The aircraft was a dream to fly. Visibility was outstanding. The controls were light and precise. The speed was exhilarating. And then he pushed the nose up, climbing past 15,000 feet. The engine began to wheeze. The power vanished. Harker tried to simulate a dogfight against an imaginary Messerschmitt and quickly realized he was utterly defenseless. In real combat, he would have been shot out of the sky. But Harker wasn't discouraged. He was inspired because he knew something the Americans didn't. Rolls-Royce had just perfected a revolutionary new engine, the Merlin 61. It was an absolute beast, a two-stage, two-speed supercharged marvel created by an engineer named Stanley Hooker. Stanley Hooker was a brilliant mathematician who had turned his talents to engineering. He had become obsessed with solving a single crucial problem. How do you force air into an engine when there's barely any air to begin with? At 30,000 feet, the atmospheric pressure is less than a third of what it is at sea level. An engine designed for low altitudes will simply suffocate and die. The answer was compression, but simple compression was not enough. Hooker engineered a supercharger with two distinct stages. The first stage would compress the thin air, then the second stage would compress it yet again. Between these two stages, he added an intercooler, a small radiator designed to cool the compressed air before it entered the second compressor. Why did this matter? Cold air is far denser than hot air. Denser air packs more oxygen. More oxygen enables a powerful explosion. The Merlin 61 could generate over 1,400 horsepower at 23,000 feet. It could breathe where Allison gasped. It could transform the thin, frigid air of the upper atmosphere into raw, explosive power. Harker landed the Mustang, marched into the engineering department, and made his audacious proposal. Let's put a Merlin in this thing.
The engineers laughed at him. The Merlin was designed for the Spitfire, It was heavier than the Allison. It needed a much larger radiator. It would completely destroy the Mustang's delicate center of gravity. The plane would become unstable, nose-heavy, and lethally dangerous. But Harker was persistent. He lobbied his superiors at Rolls-Royce. He pleaded with the Air Ministry. He wouldn't let the idea go. Finally, in July 1942, Rolls-Royce relented. They pulled 5 Mustangs from the assembly line to begin the surgery. The project was codenamed Mustang X. The X stood for experimental. Everyone involved fully expected it to fail. The first major hurdle was the engine mount. The Merlin was both longer and heavier than the Allison. The mechanics had to completely re-engineer the engine compartments. They had to drill new holes, fabricate custom brackets, and reinforce the firewall. It was grueling manual labor done with basic hand tools inside freezing hangars in Britain. The engine alone weighed more than 1,700 pounds. When you add the propeller, the coolant, and the oil, you're looking at nearly a ton of weight hanging off the very front of the aircraft. The engineers were terrified the plane would simply tip forward during takeoff, causing the propeller to shatter against the runway. They ran endless calculations. They moved ballast around. They relocated equipment. It was a precarious balancing act, measured in fractions of an inch. The second challenge was cooling. The Merlin 61's 2-stage supercharger generated double the heat of the Allison engine. The original Mustang radiator was nowhere near adequate. It would cause the engine to overheat in minutes. So the engineers added a second radiator. They mounted it directly under the nose in a new chin scoop. The main belly radiator would handle engine coolant, while the new chin radiator would service the intercooler and oil systems. It looked clumsy, asymmetrical, like a crude afterthought bolted onto a work of art. But then they started it. The Merlin roared to life. It was louder than the Allison, with a deeper, more violent tone. The entire airframe vibrated with power. And when the test pilot, a Rolls-Royce engineer, took it for its maiden flight, he radioed back a single, breathless word: unbelievable. The Mustang X climbed like a skyrocket. At 20,000 feet, it was still picking up speed. At 25,000 feet, it blazed past 420 miles per hour. At 30,000 feet, it was faster than anything the Germans could put in the air. The performance wasn't just better, it was utterly transformed. The aircraft had gone from a middling performer to an apex predator. When the official test data came in, the numbers were staggering. The Merlin-powered Mustang could achieve a top speed of 441 miles per hour at 25,000 feet. It had a service ceiling above 40,000 feet. It could climb at a rate of 3,500 feet per minute. And thanks to the Mustang's efficient airframe and huge internal fuel tanks, it had a combat range exceeding 1,000 miles with drop tanks. A perfect body without a powerful heart is useless. That last number was the crucial one: 1,000 miles. That meant the Mustang could fly from bases in England all the way to Berlin and back with enough fuel left over to fight. It was the first single-engine fighter in history that could escort heavy bombers into the heart of Nazi Germany and see them safely home. The U.S. Army Air Forces suddenly paid attention. The very plane they had dismissed was now the one they needed most desperately. In August 1942, North American Aviation was awarded a contract to mass-produce Merlin-powered Mustangs in America. But there was a catch. Rolls-Royce couldn't make enough engines. They were already at full capacity building Merlins for Spitfires, Hurricanes, Lancasters, and Mosquitoes. Every single engine was accounted for. So the Americans struck a deal. The Packard Motor Company in Detroit would manufacture the Merlin under license. They designated it the Packard V1650. It was the same engine, but it would be mass-produced on American assembly lines by workers who just a year prior had been building luxury automobiles. Now they were building weapons of war. Packard didn't merely copy the Merlin, they Americanized it. British engines were traditionally hand-built, with parts individually fitted by master craftsmen. American mass production demanded perfect interchangeability. Packard re-engineered hundreds of components. They converted all the British imperial measurements to American standard units. They completely redesigned the manufacturing process from the ground up. By the war's end, Packard had produced over 55,000 Merlin engines, more than 1/3 of all Merlins ever made. and they did it faster and more cost-effectively than Rolls-Royce ever could. The first American-built Merlin Mustang, designated the P-51B, flew on November 30th, 1942. It was everything the Mustang X had promised and more: fast, powerful, long-ranged, and lethal. By early 1943, North America was churning out hundreds. By mid-1943, thousands were rolling off the line, and in late 1943, they arrived in Europe to fight. The 8th Air Force, based in England, had been conducting daylight bombing raids over Germany since 1942. The strategy was straightforward. American B-17 Flying Fortresses and B-24 Liberators would fly deep into enemy airspace, destroy vital targets like factories and rail yards, and cripple the Nazi war effort from the air. The bombers were heavily armed. They flew in tight defensive formations with overlapping fields of fire. The prevailing doctrine claimed they could defend themselves. That doctrine was tragically wrong. German fighters swarmed the bomber formations like angry hornets. Messerschmitt 109s and Focke-Wulf 194s attacked from every conceivable angle. The bombers had guns, but they were slow, lumbering targets. The Luftwaffe pilots learned to attack head-on, exploiting the bombers' blind spots. They used rockets, cannons, and even ramming tactics. The losses were catastrophic. On October 14, 1943, the 8th Air Force dispatched a raid against ball-bearing factories in Brunswick. Of the 291 bombers sent, 60 were shot down. Another 17 were damaged so badly they were scrapped. Over 600 airmen were killed or captured. That day became known as Black Thursday, and it was devastating proof that without fighter escorts, the entire daylight bombing campaign was doomed. What was the problem? Range. The P-33 Lightning and P-47 Thunderbolt were excellent fighters, but they lacked fuel capacity to fly to Berlin. They could escort the bombers part of the way, but then they had to turn for home. After that, the bombers were alone and vulnerable. But in December 1943, the Mustang arrived, and the entire dynamic of the air war changed. The first Mustang escorted mission took place early in 1944. The target was Brunswick. The bomber crews were on edge, having been decimated on previous raids. But this time, as they crossed into German airspace, they witnessed something new. Mustangs, dozens of them circling high above, waiting. When the Messerschmitts appeared, the Mustangs dove on them like birds of prey. The German pilots were accustomed to fighting the heavier, less agile P-47s. The Mustang was a different breed. It was faster and more nimble. It could turn inside a Bf-109. It could outrun a Focke-Wulf 194, and its 6.5 caliber machine guns could shred an enemy fighter in a matter of seconds. The grateful bomber crews started calling the Mustangs their little friends. And the pilots cherished that name because they knew they were keeping those friends alive. It became the guardian angel of the sky. By March 1944, Mustangs were escorting bombers all the way to Berlin and back. The Luftwaffe tried to counter, throwing everything they had at the Americans, but the Mustangs were relentless and seemingly unstoppable. The German pilots began to feel a sense of dread. The tactics also evolved. Early on, fighters were instructed to stay close to the bomber formations, a defensive and reactive strategy, but the Mustang possessed the speed and range to hunt offensively. Fighter commanders developed a new doctrine of layered protection. Some Mustangs would fly a tight escort with the bombers, while others ranged far ahead, actively clearing the skies of threats. When the Germans did attack, the outer layer of Mustangs would dive on them from above, breaking up their attack formations before they could even get close to the bombers. The Mustang pilots called this tactic the bounce. They would climb to 35,000 feet, far higher than German fighters expected. They would orbit in the glare of the sun, making themselves nearly invisible, and when the enemy fighters lined up for their attack run on the bomber stream, the Mustangs would plummet out of the sky like meteors at full throttle with guns blazing. The Germans often never even saw them coming. Hermann Göring, the commander of the Luftwaffe, famously said that when he saw American fighters over Berlin, he knew the war was lost. But the Mustang pilots didn't just defend, they hunted. When the Luftwaffe was reluctant to engage, the Mustangs went looking for a fight. They followed German fighters back to their own airfields. They strafed runways. They destroyed aircraft on the ground. They hunted trains, trucks, and supply columns. These missions were called rhubarbs, or rat catching,
and they were incredibly effective. But ground attack missions were exceptionally dangerous, even more so than dogfighting. When strafing a target on the ground, a pilot had to fly low, slow, and predictably. Every soldier with a rifle would be shooting at you. Every anti-aircraft gun was tracking you. The Merlin engine was liquid-cooled. A single bullet hitting a coolant line meant the engine would overheat and seize within minutes. The oil system was just as fragile. Pilots called it getting tagged. Once tagged, you had maybe 5 minutes to find a place to land before the engine tore itself apart. Despite the immense risks, these ground attacks paralyzed the German war machine. Trains stopped running, supplies couldn't move, and airfields became death traps. The few German Luftwaffe pilots who survived the air battles often returned to find their planes destroyed on the ground.
He bailed out, evaded capture with the help of the French resistance, and escaped through Spain back to England. Military policy stated that evaders could not fly combat again. If captured a second time, they might reveal resistance networks under torture. But Yeager appealed directly to General Dwight Eisenhower. Recognizing Yeager's incredible skill and drive, Eisenhower made a rare exception. Yeager returned to the war. On October 12, 1944, Yeager became an ace in a day, shooting down 5 German fighters in a single mission. 2 of them were destroyed without him firing a single bullet. He maneuvered so aggressively that one Messerschmitt collided with its own wingman while trying to escape him. 3 more fell to his guns in a chaotic dogfight that lasted less than 10 minutes. Later that year, Yeager encountered a Messerschmitt Me-262 jet fighter. The 262 was the future, a twin-engine jet capable of 540 miles per hour, faster than any Allied plane. The German jets were supposed to be untouchable, but Yeager caught one on its landing approach when it was slow and vulnerable. Yeager dove through a storm of anti-aircraft fire, opened up with his 650s, and blew the jet to pieces just before it touched down. Destroying a jet with a propeller plane wasn't supposed to be possible, but the Mustang made the impossible routine. By the spring of 1945, the Luftwaffe was broken. They had lost their most experienced pilots. Their fuel supplies were gone. Their airfields were cratered. The Mustang had shattered them, not by outproducing them or outgunning them, but by outlasting them, by being everywhere, all the time, at every altitude, over every target. The Merlin engine gave the Mustang the power to fight at 35,000 feet. The laminar flow wing gave it the speed to chase down anything. The Meredith Effect radiator turned drag into thrust, and its massive fuel capacity gave it the range to escort bombers into the heart of the Third Reich and bring them safely home. It was the perfect weapon. But it was born from a fortunate accident, a bold gamble, a mechanic's wild idea that maybe, just maybe, you could combine an American airframe with a British engine and create something far greater than the sum of its parts. Edgar Schmued designed the body, Stanley Hooker designed the heart, Ronnie Harker played matchmaker, and Packard built the engine by the thousands. It was an engineering hybrid, a monster of 2 nations, and it worked. The P-51 Mustang wasn't just a fighter, it was living proof that sometimes the best solutions don't come from a clean slate. They come from smashing 2 great ideas together, even if everyone tells you it's impossible, even if the physics says it shouldn't work, even if it means tearing the nose off a perfectly good airplane and bolting on an engine that was never meant to be there. Because sometimes the thing that doesn't belong is the very thing that wins the war. By the time World War II ended, over 15,000 Mustangs had been built. They served in every theater of the war: Europe, the Pacific, North Africa. They escorted bombers, strafed targets, fought jets, and dominated the sky. They kept flying. In Korea, in civilian air races, and in the hands of collectors who knew they were piloting a legend. The last operational military Mustangs weren't retired until 1984 in the Dominican Republic, 44 years after the prototype first flew. That isn't just longevity, it's immortality. The Mustang still flies today at air shows, a testament to the pilots who understood they weren't just flying an old plane, they were flying the plane that helped save the world. It's the plane that proved you don't need to be the biggest or strongest. You just need to be smart enough to put the right pieces together at the right time. The Allison engine was good, the Merlin engine was great, but the Mustang airframe was perfect. And when you combine perfect with great, you get something unstoppable. You get a plane that can fly higher, faster, and farther than anything else. You get a plane that can turn the tide of a war. And you get a timeless story. A story of a British test pilot who refused to accept failure. A story of a German-American engineer who believed in pure efficiency. A story of American factory workers who built British engines in Detroit and shipped them to California to be put into American airframes that would rule the skies over Europe. A story of international cooperation in the midst of a global conflict. A story about taking a flawed design and transforming it into a masterpiece. That is the story of the P-51 Mustang. The plane built in 120 days. The plane rejected by the Army. The plane that was helpless above 15,000 feet. The plane that should have been a forgotten footnote. The plane that demonstrated collaboration is better than isolation. The plane that showed American ingenuity and British engineering could create something neither country could have built alone. It was a good plane until one man decided to rip out its heart and give it a bigger, stronger one that didn't belong. And that's when the Mustang stopped being just a plane and became a legend.